Swayam Prabha. Digital India. Educated India.
Welcome to the course on micromachining, DTH sponsored course. I am now going to talk about electrochemical deburring for macro as well as micro applications. What we have done in the last lecture on electrochemical grinding, introduction to electrochemical grinding, where I introduced the working principle of electrochemical grinding, compared the conventional grinding and electrochemical grinding. Then comparison of different processes, that is conventional and electrochemical grinding process performance, effect on material removal rate, tolerances, etc. Variants of ECG, 4 different variants of ECG I had explained to you over there. Then material removal analysis of ECG was also discussed to some extent, because I have already discussed in detail in electrochemical machining, so I am not repeating it. Electrochemical grinding process performance, and some very small number of applications we have discussed. You can find many other applications in the paper which I have given as the acknowledgement for electrochemical grinding, and finally the conclusion. Now I am going to talk about electrochemical deburring. So organization of the talk is surface technology and word definition, types of burrs formed during different manufacturing methods or manufacturing processes, deburring and electrochemical deburring. What is deburring? Further, electrochemical deburring, applications, and then finally conclusions. These are the acknowledgements of advanced machining processes where electrochemical deburring has been discussed in a chapter. And Naidu, M.G.J. Naidu, who delivered a talk on electrochemical deburring for quality production, and this company has also made electrochemical deburring machine tools available in the market. Surface technology and burr definition. The discussion deals with both micro as well as macro burrs. So please don't get confused that it is only with micro burrs, it is also applicable for macro burrs or meso burrs also, depending upon what is your requirement. So you can apply these principles and machine tools for the both. Concepts of surface technology. Let us try to understand the parameters of surface technology, like luster, reflection, contact problems, fitness, because if surface is not properly finished, burrs are there, scratches are there, then you will have the problems like reflection. While you are contacting, then burrs will be in between the two and life will go down. Fitness will not be proper, oil or air tightness will not be obtained because burrs are there in between the two matching parts. Electric or thermal conductivity will be affected because of the burrs, etc., scratches, etc. Friction, lubrication and wear addition problems will be there, and as per your design it may not work properly. Magnetic characteristics will change, because we already know that at the sharp peaks, etc., magnetic field is very different from the flat surfaces comparatively. Then fatigue strength also will be different. Stress corrosion may take place, rust will be there, and plating of these surfaces may overcome to some extent, but not to the large extent. These problems will be there. Painting can be used for that purpose. All these problems are going to affect function and performance of the surface. Performance of surface of the part will be affected if these problems are there. So the best thing to done is to remove the berth before putting the component into the assembly or in the use. So you can see here, these are controlled by surface texture. These things, they are come under surface texture, edge quality, surface integrity, and surface modification. So these are the four major terminology which control these parameters. Surface contours and dimensions, they come under surface texture, edge quality. Then you have surface technology, all this comes under this category. So what we are going to do in this particular lecture is we will try to control all these, some of these parameters, so that the surface texture, surface quality, surface integrity becomes better. And if this is better, then definitely the life of the product will be higher, it will be economical, and it will perform better. And all this depends upon machining accuracy. What method or machining method you are going to use, that will affect this. But whatsoever you are using, under certain conditions, you are going to get the burrs, you are going to get the scratches, and for removal of this, you have what is known as electrochemical deburring process. So this is the source from where these particular details have been taken up. Introduction to electrochemical deburring. A designer considers the points such as material, form dimensions, surface finish, etc. What about surface integrity and edge quality? Normally, while designing a part, surface integrity and edge quality, they are not taken into consideration, and they are assumed to be perfectly all right after machining or forming or grinding, which is really not true. It affects both performance as well as product life. If you are not considering edge quality, if you are not considering surface integrity, then your design may prematurely fail, product may prematurely fail. So this is very important. So machining of materials by conventional methods we have discussed. Macro and micro burrs specifically at intersecting surfaces, and in the assembly there may be many intersecting surfaces which are having edge quality problem and burrs are there. So there are certain undesirable effects of this. Performance of components will be affected. Safety of operators or users, this is another very important. If sharp edges are there and while assembling, it may lead to bleeding of the assembler or the operators, and this is really a big problem. Hence, removal of burrs becomes essential requirement before really putting any part into the assembly or in the use. Various types of macro burrs obtained during drilling operation. Not only macro burrs, you can also obtain micro burrs depending upon what is the size of the hole that you are drilling. And drilling burrs, you can see here, these are the three types of drilling burr of AISI itna material. You can see the uniform burr over here, transient burr over here, you can see this, and crown burr over here. So different kinds of the burrs you can obtain. These are definitely for macro burrs. but you can obtain in micro holes also. Exit burr, uniform burr is seen over here. If you see at outer surface, these are the burrs, and you have the entry burr at the entry where the drill is entering and where the drill is exiting. Then again transient burrs kind of the thing. Here they are bigger one, these are the smaller one, and you have to really remove them before putting them into use, and again entry burr is over there. So these are the different kinds of macro burrs. You can have similar kind of micro burrs also, depending upon what kind of operation you are performing. Now this I have shown to you in the ECG also, electrochemical grinding part also, because this is the part performed by ECG and this is the part performed by machined by milled by, where you have the burrs, micro burrs and scratches and rough surfaces. Gas turbine component, tough superalloys and slot produced by conventional milling over here. So under these conditions you will definitely require electrochemical deburring, or for that matter you can use other deburring method also, but electrochemical deburring has its own merits and demerits. We will see some of them. Micro deburring applications of MAF. Now you can see here, this is the micro burrs which were obtained after drilling a hole, and you can clearly see in white color and black color also. And there is a process called magnetic abrasive finishing, MAF. With the help of MAF, this part was finished or deburred, and you can clearly see all those burrs are removed from this, all these burrs are removed from this part. This is the another view after deburring of the same part, so you can see clarity of that. So drilled hole H before deburring, and this is after deburring. These micro burrs can be easily removed by electrochemical deburring very easily also. This is done by MAF process, but electrochemical deburring can also be used for this purpose. How to define a burr? That is another problem. So some simple definitions have been given by Naidu, but there may be many other definitions in the literature. It is three-dimensional, as you can see here. Burr, this is having the length, this is having the height, and this is having the thickness. This is the burr over this particular surface. Burr length is there, length of the edge along the burr axis. Then you have the burr height, that is the height over here, and then burr depth, thickness of the burr, where it joins the parent material. This is the thickness, and it is the parent material over here, and it is joining the parent material over here. In this zone, it is joining the parent material, so you can clearly see it. Types of burrs formed during different manufacturing processes or methods. Very interesting. You can see over here, this is the compressive burr. This one is the compressive burr, the burr produced in blanking operation and piercing operation, in which slug separates from the parent material under compressive stress. You can clearly see here, this is the part where you are getting this kind of the burr. Then you have the cutting of burrs. In this particular case shown over here, a projection of material left when the workpiece falls from the stock. Then you have the corner burr. You can clearly see this is the corner burr, intersection of three or more surfaces. You can see over here, these are the corner burrs. Then edge burrs, this is clearly visible over here. Intersection of two surfaces, these two surfaces, and this is the edge burr. And then you have the entrance burr and exit burr. Entrance burr is the one where drill is entering the surface, and this is the entrance burr, and where drill is exiting the surface, this is the exit burr. So at both the ends, exit and entrance, you can have the burr. Then you have the feeder burr, as shown over here very clearly. This is the feeder burr, and then you have the flash burr, Then you have the hanging burr, loose burr not firmly attached to the workpiece, that is the hanging burr. And then you have the roll over burr. Now burr formed when it exits over a surface and allows the chips to be rolled over. So you can clearly see rolling of the burr. And then you have the tear burr. So you can see clearly different kind of the burrs that are formed under different kinds of the operations. Now all of them have to be removed before really you put them into function. So functional problems with the burrs. In manufacturing, handling of these components having the burrs is very difficult and dangerous for the operator or the person who is handling them. Machining is also a problem. Assembly is definitely a problem. Positioning of the part in the assembly is again a problem because of these burrs. Checking and finally mounting are endangered, so they have to be removed. Workpiece, corrosion after coating, even after coating, the parts may get corroded because of these burrs. Crack formation in loading, when you are loading them, then the cracking may take place. Then equipment, when you are assembled, you have assembled them, wear and or breakdown by loosened burrs will take place. So you can see at all the fronts, these burrs are creating the problem. So they have to be removed before really putting them into operation. Physiological problems, as some of them I have mentioned, injury may take place to the operators or the person who is assembling it. Injury during processing, assembly, maintenance and repair may take place. Utility problems during gripping surfaces, tools and handling elements. This is very common that while you are handling the part having the burrs etc., sharp edges etc., the person who is handling may get hurt, may get bleeding over there. Then aesthetic problems are also there with the burrs in the components. Advertising, sale and use also are affected if burrs are there in the component. Deburring. So burrs are to be removed. So the operation where you are removing the burrs, that is known as deburring operation. Removal of burrs is known as deburring. Now there are various kinds of the methods by which you can remove the burrs. Electrochemical grinding is one of them, not the only one, it is one of them. So you can have mechanical deburring where burrs removed by tumbling, blasting etc. result in non-uniformity. If you are using these methods, tumbling, blasting etc., then you will get non-uniformity of the removal of the burrs, low material removal rate, charged with grits, because you are removing these burrs with the help of the grits of the abrasive particles, so they may get penetrated into the workpiece, that is known as charged with grits, and this is highly undesirable. Then thermal deburring, because these burrs are very sharp and very fine, very small thickness. We have already seen various kinds of the burrs. So if you subject them to a very high temperature, then they may get burned out or they may get removed from there. So magnetic field assisted deburring is there. Apart from the thermal deburring, you can have the magnetic field assisted deburring. I have already shown to you one example by MAF process. Then you can have abrasive flow finishing assisted deburring also, because all kinds of finishing processes, nano finishing processes can be used for deburring purposes. Then electrochemical deburring based on ECM principle, that is what we are discussing today. Deburring process. Much of this research and development has now made the transition from the laboratory into the production. They are very commonly used on the shop floor for deburring purposes. Lot of research has already gone into it. Mechanical deburring methods, as we can see here, with the help of the abrasive particles, you can remove the burrs by vibratory finishing, barrel tumbling, spindle finishing, centrifugal barrel finishing, magnetic luge deburring, reciprocal finishing. I am not going to go into the details of these methods, because my basic concern in this lecture is electrochemical deburring. Hence, I am just telling you various techniques which are used for deburring purposes and flow finishing. Second is mechanical, where hand brushing is done for removal of the burrs, power brushing, mechanized scraping. Liquid abrasive flow finishing, this is one of the nano finishing processes which is used for deburring purposes. Semi solid abrasive flow finishing, again finishing process is there. And then you have abrasive water jet finishing, it can also be used for deburring purposes and finishing purposes. We have already discussed abrasive water jet machining process. It does not produce high edge quality. Whatever these methods are shown over here, majority of them do not produce high edge quality, because fine micro burrs still remain over there after mechanical deburring. That is why normally people recommend electrochemical deburring for high or better performance. Tumbling machine, this is the tumbling machine, you put the product over here, abrasive particles are there and they are rotated and moved up and down over here, with the help of which you can remove the burrs. Normally macro burrs can be easily removed, to some extent only micro burrs can be removed. Tumbling machine to bring out rolled, eased and better edges, giving the surface an anti-glow. This is the source. Soda blasting, please see here, this is the material, that is, this is the workpiece surface or substrate, and this is the container. You are applying this liquid material which is removing the burrs, and you know we have already seen different kind of the burrs which are very loosely entangled with the workpiece. So when you are applying the forced liquid, you can easily remove those burrs from the surface. So soda blasting is a process where a surface is cleaned, rust is neutralized, or coating of any kind are stripped off from a substrate. The surface beneath the material you are trying to remove, it also removes micro burrs. So this is what many industries are using for deburring purposes. This is the source. Thermal and electrochemical deburring processes. Thermal processes, as I have already mentioned to you, that burrs are of very small cross section, very thin, and maybe micro or maybe macro, depending upon the size of the burrs. You can use the thermal process. Torch or flame is used for melting purposes, and it quickly melts because they are very thin. Thermal energy method, plasma, hot wire, resistance heating, etc. can be used for this particular purpose. Then you have electrochemical that we are going to discuss: electrochemical vibratory, electrochemical barrel, electrochemical centrifugal barrel, electrochemical spindle finishing. Now, micro deburring using nano finishing processes, I have already told you, they are in the introductory lecture also. I have given you various nano, micro, nano finishing processes. They can be used for deburring purposes, and I have already given today the example of magnetic abrasive finishing process being applied for micro deburring. This is the one of the machines used for nano finishing. You put the component and perform the nano finishing process, micro burrs will be easily removed. So you can see here this kind of the burr which is macro burr, it can be removed. This is before and this is after finishing. Now this is very interesting one. This is deburring and edge finishing. It is the front part of the book which has been taken. You can see here, this is the conventional kind of the grinding sheet or disc which is removing the burrs, micro or macro burrs from here, and it is finishing the edge of these or the teeth of this gear. Very interesting application. Now you can see here, this is before finishing and this is after finishing or after deburring. So you can see the difference in the quality of the holes before and after. Now you can see here, these are the burrs. This is the burr which is visible over here. This is before finishing and this is after finishing the edge. There is no burrs over here. This is before finishing and this is edge is after finishing. So now you can see the difference between this, and this has not been very accurately because little part is left over here. So all this depends upon how you control the machining parameter over there. Now combustion principle of the thermal deburring process, this is very important. The part which is to be deburred, you can place over here. This is the deburring chamber. This is a chloride plate is there, gas, oxygen is there where you are burning. Because of burning, very high temperature is created. So effect of gas mixture on the workpiece geometry, burrs are burned up. You can see here, these are the burrs. This is the burr which has been burnt out, and this is the clean one, and this is another clean one. So you can remove the burrs accordingly. Deburring in seconds with thermal deburring system from the Roxroth Bosch, because here deburring is done in the seconds. Very small time is taken because it is a thermal process. You are not removing the burrs mechanically. Thermal energy easily removes burrs produced by turning, milling, broaching, etc. and grinding, as well as burrs resulting from die casting. How does thermal deburring burrs? The workpiece to be processed are placed in a pressure chamber. In thermal deburring method, the chamber is filled with gas mixture as shown over here. Gas, oxygen, etc. are there and they are ignited. Suitable combustible gases are hydrogen, methane and natural gas. The temperature increases within milliseconds. Noted, it is milliseconds, not few seconds, to between 2500 to 3000 degrees centigrade. And at this temperature, all these micro burrs or even macro burrs, they will get melted out from here and separated out. When the gas mixture is ignited, due to their high surface to volume ratio, the burrs on the workpieces absorb radiant heat. This results in the accumulation of heat that burns up the burrs. The resulting oxide is deposited on the workpiece surface, as you can see over here. Deburring in seconds with thermal deburring system from Roxroth Bosch. Thermal energy easily removes burrs produced by turning, milling, broaching and grinding, as well as burrs resulting from die casting. How does thermal deburring burrs? The workpiece is to be processed, placed in the pressure chamber. In the thermal deburring method, the chamber is filled with gas. I have already explained it to you. This also I have already explained to you and I have shown it. Deburring process. There are various ways in which deburring can be done. We have already seen. One of them is chemical deburring, chemical barrel finishing, chemical spindle finishing, chemical vibratory, chemical, magnetic, loose, abrasive finishing. Electrochemical deburring machine tool. Electrochemical deburring machine tool, insulated except a part adjacent to burr is bare. I will show you. Dimensions of barrel part of tool, machining time and machining conditions are fixed according to the size and shape of the burrs. And it is normally done by trial and error method. No mathematical modeling is available for any kind of parts. You can see here electrochemical deburring setup diagram for removal of burrs. You can clearly see this is the gap between this part. Please note it carefully. This gap is between this part here as well as here. This is the gap, not really this line. And then you have the electrolyte flow through this gap all around this cathode. This is the shield, this is the workpiece which is to be deburred. Electrolyte supply is there all around this, and then insulated coating. This is the insulated coating to this part, because you are going to remove the burr from here only. This part is only deburred. So, you have the coating up to this part, and whatever is opposite to this burr, that is kept as bare part. So, current will flow from this part toward this part, and electrolysis will take place for electrochemical deburring process. In electrochemical deburring, current, electrolyte flow rate and electrolyte pressure are all low, because here material to be removed is very small, depending upon the size of the burr, whether it is micro or macro. Tool is stationary. Here tool is stationary, nothing is moving up or down, only electrolyte is flowing and current is flowing between the burr and this part of the cathode, that is the tool. So, electrochemical dissolution is going to take place for electrochemical deburring. It is useful in the inaccessible areas. This is very important benefit of this electrochemical deburring, where other methods do not work or they cannot work. Electrolyte used is sodium chloride or sodium nitrate or other type of electrolyte that will be decided according to the type of the workpiece material. Electrolyte supply system, high velocity electrolyte flow, electrical power system, mechanical structure for workpiece and tool mounting. As you can see over here, this is the structure where workpiece is mounted and the tool is mounted over there. And sludge separator is there, which is not shown over here. Electrochemical deburring machine tool further, multiple workstations or single power supply. Electrolyte is recirculated after filtration. This is very important. When multiple workstation means you are deburring at many locations at the same time. So, accordingly you have to design the tool. Electrolyte is recirculated. I have already mentioned that first thing, electrolyte is very expensive. Second thing, there is no electrolyte consumption. So, after filtration, electrolyte is recirculated. For proper deburring, work characteristics should be known. So, let us see. A flexible tool for removal of burrs at the intersections of curved passages. that you can see over here. This is the flexible tool for removal of the burrs. Here you can see different parts. One is the insulated part over there, insulation, and two is the copper tip with a hole for electrolyte supply. This is the copper tip and hole is there for the electrolyte supply. Then 3 is the spring, this is the spring. 4 is the PVC sleeve, this is the sleeve, and 5 is the copper shank press fitted to the spring, this is the copper shank. So, these are the different parts of a flexible tool electrode for deburring purposes. Material, electrolyte, applied voltage, current density, deburring time. So, you can see here for different materials you can use different type of the electrolyte. However, here in almost all cases except one, sodium nitrate is being used as the electrolyte with different percentage, and for stainless steel it is the NaCl, and for other materials like carbon, low carbon steel, copper alloy, aluminum alloy, this is sodium nitrate. But there are various kinds of the material for which you will require different type of the electrolyte. So, you have to choose it carefully. Applied voltage range is 12 to 24 volt depending upon the shape and size of the burrs. You can choose this voltage. Then current density normally is ranging between 5 to 10 ampere per centimeter square, and deburring time depends upon the size of the burrs, and this varies from 5 to 100 seconds. Size, which will include length, height and thickness, that we have already seen in the earlier slides. Deburred sample characteristics, again almost the same thing which is being shown over here. This is a typical burr, you can see over here. This is the gap, this is the part fitting over here, this is the anode, contact point is there, and other things we have already seen. Now, this is important to see the shape of the deburred edges, corner, part, whatever it is. Now, this is the kind you can see here. This is not as uniform as you can expect over here after deburring even, and this is the part which is left. So, depending upon the design of the deburring tool, deburring parameter conditions, you will get the final shape and size of the deburred component. So, these are the tracings from the micrograph of the deburred samples. As I mentioned, these are the deburred, but still there are avenues which can be improved over there as long as deburring is concerned. Other applications, biomedical applications, there are so many biomedical applications which are important, consumer appliances, aerospace industries, automobile industry and so on. Components that have burrs and that can be deburred by these processes are gears, splines, drill holes, etc. Wherever you are machining, especially conventional machining and grinding, you will have the burrs, and those burrs have to be removed before really putting the component into the assembly or in the use. Higher reliability, reduced operation time and more uniformity for the electrochemical deburring process. Electrochemically deburred gear, you can see over here, this is the before deburring, lot of burrs are there, rough surfaces are there, and this is after deburring. So, you can see clean deburred surface of the gears, a gear before and after deburring taken from this one. Sorry, stop. Sorry, कौन है यार पलक. So these are the deburred parts you can see over here. Conclusions: electrochemical deburring is an accurate and comparatively faster deburring process as compared to other processes which we have already seen. Electrochemical deburring is equally applicable for both macro and micro deburring. Thank you very much.